So welcome everybody. Today we are pleased to present the 8th session of the Future Scientist, in which Dr. Alex Gomez-Marin will be in conversation with our very special guest, Professor Avi Loeb. Avi Loeb is a professor of science at Harvard University and best-selling author of 8 books on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. Professor Loeb has held many prestigious appointments and is now the director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics, and also serves as the head of the Galileo project. It is a pleasure to welcome you to the PARI Center. And welcome back to our resident conversationalist, Dr. Alex Gomez-Marin. Alex is a Spanish theoretical physicist turned neuroscientist, and since 2016, he has been the head of the Behavior of Organisms Laboratory in Alicante, Spain, where he is an associate professor of the Spanish Research Council. And with that, I hand it over to both of you. Welcome.
Thank you so much for having me. We could have saved some time if you just introduced me as a farm boy. Go ahead, Alex.
Well, so let's start with that, because I've heard and I've read and that you said if you weren't a scientist, you most likely be happy in a farm. So that's an excellent place to start, given how successful your career has been. And since we'll talk about experts and the future of science, well, I think it's really strong and important to have that plan B, which is a very good plan B.
Well, I wouldn't regard it as plan B. In fact, I sometimes consider it as plan A. Every morning when I jog at 5 a.m., looking at the sunrise in the company of ducks, birds, bunnies, and wild turkeys, I really enjoy the company of nature, much more so than the company of people. And this came out of my childhood on the farm. That's why I don't have any footprint on social media. And as a child, I was interested in the biggest questions, which were in the realm of philosophy. I was naive enough to think that by studying philosophy, we can perhaps get better answers to these fundamental questions. Unfortunately, the answer is we don't have good answers. I was out of circumstances. I had to serve in the obligatory military service when I grew up in Israel, and I prefer to do intellectual work. And they allowed me to do a PhD in physics. And for me, it was a good approximation to philosophy. Actually, the degree is in philosophy of nature, so to speak. And then one thing led to another. I was offered a position in astrophysics, and I ended up realizing that I'm actually married to my true love, even though it was an arranged marriage, because in astrophysics, we do address the most fundamental questions. So if you think about it, science offers us an opportunity to answer these questions. And therefore, I'm quite happy ending up where I am. It's not so much the titles that I acquired, that is completely irrelevant. It's the ability to engage with fundamental questions using the scientific method. Now, what do I mean by the scientific method? That we put aside our ego, we put aside thinking about ourselves at the center of the universe, everything is centered on us, everything is about us, which is pretty much what you find on social media. It's not about us. We just came at the end. The universe existed for 13.8 billion years since the Big Bang. We are not at the center of the stage. And so let's be humble and let's just look at evidence. That's the scientific method, being guided by evidence, looking around and learning. Nature educates us. And that is pretty much my philosophy, listening to nature, not listening to people, because people very often are swayed by their ego, by their pretension to be experts, meaning that everything can be explained based on their past knowledge, because that's how they get awards, that's how they get funding. And so this realization came to me, gradually throughout my life, but it's pretty much consistent with my childhood.
As I expected, Avi, a rush of nuggets, incredible nuggets to unpack. Okay, so we don't have good answers. Do we have good questions, at least?
Yeah, we have very good questions. For example, what happened before the Big Bang? the universe started in a Big Bang. We know that because the universe is expanding. And when we reverse the movie backward in time, we can, using the laws of physics, expect something to have happened early on. And we see those things. We see the cosmic microwave background from the hot, dense phase of the universe. We see the small ripples in temperature, the small density fluctuations early on. So we have an image of the universe 400,000 years after the Big Bang. So when we go back in time, the universe appears to be consistent with this mental picture that the density went up and up as you go back in time, and it was infinite at some point in time, 13.8 billion years ago. What happened before that time, we cannot tell, because Einstein's equations of gravity break down. And they break down for a good reason, because quantum mechanics is not incorporated. So the question is, what happened before? And that is, the first chapter of the Old Testament deals with the question, how come the universe was, came into existence? Einstein actually, interestingly, Einstein resisted the notion the universe started at a point in time, and tried to sort of find solutions to his equations that admit a universe that existed forever, and he failed. There is no such solution. Either the universe contracts to a point or expands the way we see it. And the question is, what happened before? And, one possibility is our universe was created in the laboratory of a civilization that is able to unify quantum mechanics and gravity and can engineer that so that they produce a baby universe in the lab. So once we reach that level, when we can produce a baby universe in our lab, it's sort of like generations of people that babies grow up and they can give birth to new babies. Maybe that's one solution.
That kicks the question further back, right? In a kind of infinite regress.
Well, you can ask what came first, the chicken or the egg, and by the way, the answer is something else. It was not, if you look at the evolution of chicken, obviously chicks come out of eggs and eggs come out of chicken, but there was something else before that that looked like an egg, but wasn't a chicken that laid that. And so it's okay. So you can imagine an infinite cycles, a set of cycles that the universe went through, or you can imagine something else. But this is not currently a scientific question, because we don't have equations that unify quantum mechanics and gravity in a way that makes predictions. There are people that for decades are working on this problem. They were inspired by Einstein. They are called string theories. They are dominating the scene of theoretical physics, claiming that they have some hints how to unify quantum mechanics and gravity. But if you ask them, can you tell me what happened before the Big Bang? They would say, no, that's too complicated. If you tell them, can you tell me what happened at the singularity of a black hole, where again, Einstein's equations break down, they will tell you, oh, it's too difficult of a problem. We can't we can't tell you. So I ask you, suppose you invite a plumber to your home to fix the toilet, and the plumber tells you, I can't fix the toilet, it's too complicated. Then you say, okay, can you fix my faucet? It's leaking. He says, no, that's also too complicated. Then you realize, is this a plumber? So when people pretend to solve a problem, but then cannot give you solutions, I don't think, and that's over a period of several decades, it's not just over 1 year, 2 years. So people say, be patient, it may take 100 years. I'm not that patient. I think there is a critical lifetime of the lifetime of a person. Okay, if you can't solve a problem during the lifetime of your career, then you can't pretend to be a plumber. You can't pretend to be that profession of unifying quantum mechanics and gravity.
So you think then that theoretical physics, and by theoretical physics we should say maybe particle physics, or like the most fundamental, because there's theoretical physics also in stochastic thermodynamics and other realms, but you think it has been stalled for decades, and what are the reasons for them, both, I suppose, scientific and also sociological?
Well, it's a very simple reason. If you think about quantum mechanics that was discovered a century ago, okay, all of our gadgets, the cell phones, the computers, we are communicating right now thanks to understanding of quantum mechanics. And that happened only a century ago. Now, if you ask, how did we learn about quantum mechanics? It was not because people that practiced classical physics expected it. In fact, they didn't. Michelson, the guy from Michelson and Morley experiment. Michelson was a very prominent scientist 120 years ago. And he gave a lecture at Chicago, the University of Chicago, when a new laboratory was inaugurated there. And he said, pretty much physics is finished. We just have to work on, the 6th decimal point on some constants. How wrong was he? 5 years later, Einstein came up with special theory of relativity. 15 years later, Einstein came up with general theory of relativity, which changes our view of space and time. 20 years later, quantum mechanics changes completely the way we think about reality. And this guy was saying, oh, we're just done. Okay, so just to show you how wrong even the leaders of physics can be. But moreover, nobody expected quantum mechanics. It was baffling, and Einstein had a hard time understanding it. That's why he came with the Einstein-Podolsky-Rosen paradox, and he was wrong. Now, from experiments, we know that his interpretation of quantum mechanics was wrong. Niels Bohr was correct, and Einstein was wrong. Now, you ask yourself, how is it possible that we figured out something about reality that we didn't expect? The answer is simple. We just did experiments and nature educated us. It's all thanks to the feedback from experiments, unexpected, completely unexpected. Now, how can we learn about the unification of quantum mechanics and gravity? It's not by these string theorists sitting in their, isolated offices and showing us that they are smart by doing mathematical manipulations. That's not the way. The way is to be guided by experiments. So why was it stalled? Progress was stalled over the past, let's say, 4 decades, because there was no experimental data. My point is, once we start getting data about places where quantum mechanics and gravity are needed, such as the very early universe, if we detect, for example, gravitational waves from the early universe, or if we learn something new about black holes, perhaps then we will be guided to the correct theory. But before that, it's very pretentious of people to think that out of pure thought, you can come up with understanding quantum gravity, because here is the evidence. We haven't arrived anywhere. Of course, people got honors, awards. People show that they are smart by doing mathematical gymnastics. That's not progress, because, for many decades, a lot of people, 500 years ago, argued about how many angels can sit on the tip of a pin, can dance on the tip. Okay, that's an interesting question, and you can show that you are smart by discussing it philosophically, but it's not as if we know that there are angels dancing on the tip of a pin. Okay, you can show that you are smart by discussing it. You can show that you are smart by discussing extra dimensions, by discussing the multiverse, by discussing whether, reality is a simulation, all of these things. But the point is, that's not progress in our knowledge. Progress in our knowledge is getting experimental data that guides us in the right direction.
So before we talk more about experts in the face of evidence, which is 2 of the E's of this session, and then the 3rd one is extraterrestrial life. So let me ask you, do you think particle accelerators are currently a waste of money based on what you're laying out?
Not at all. Not at all. I think that's the right way, except that we invested $10 billion in the Large Hadron Collider, and all we found is old news. What I call old news is the Higgs. Of course, it's extremely important, but it's from the 60s. And so far, we haven't discovered new physics. Now, that's, a risk you always have to take, because you don't know what nature would reveal. But we invested $10 billion. Now, the lesson that I learned from that is not that we shouldn't have invested the $10 billion. I think we should have. And, we learned that the dark matter is not, the lightest supersymmetric particle in the natural range of values for its parameters. It's not that. So we invested $10 billion. We didn't find what the dark matter is, okay? And, it's not a waste of money, because a lot of people thought it's just around the corner, we will find the dark matter. My point is, at the same time, that we discovered that most of the matter in the universe is not what we find in the solar system, by the way. That's amazing. If you think about it, 100 years ago, most astronomers thought that the sun is made of the same material as the Earth, okay? And then came the PhD thesis of Cecilia Payne-Koposhkin, the first PhD in astronomy at Harvard and Radcliffe. She did it. She discovered that the surface of the sun is made of hydrogen. And Henry Norris Russell, who was on her thesis committee, he was the director of the Princeton University Observatory, he said, that's impossible. That's ridiculous. Take this statement out of your thesis. And she was a young scientist. Of course, she said, okay, well, I listened to this expert, and she took it out. He dissuaded her from putting this conclusion in her thesis. Then for 4 years after that, he tried to prove her wrong by taking data, analyzing it, and then he found that she was right. Mm-hmm. So then 4 years later, he wrote a paper saying, yes, the surface of the sun is made mostly of hydrogen. It's not the same composition as the Earth. And, that's an interesting lesson here. But beyond that, we also, Fritz Zwicky in 1933 realized that most of the matter in the universe is not the same matter that we find in the solar system, including hydrogen, including what the Earth is made of. It's not the same stuff. And since then, it's called dark matter. It's not the ordinary matter that we see in the solar system. So we are putting $10 billion trying to find it. That's completely fine. But at the same time, the mainstream of science is ridiculing the search for technological equipment from other civilizations. Yes. There is zero money, zero funding from federal agencies to that. Now, I ask you, does that make any sense? Because we sent out spacecraft to space. 5 spacecraft are making their way out of the solar system. We now know that most stars formed billions of years before the sun, and that somewhere between a few percent to 100% of all the sun-like stars have a planet the size of the Earth, roughly at the same separation. So the dice was rolled tens of billions of times just within our own Milky Way galaxy. And then there are trillion galaxies like it in the universe. And then we have the audacity to say that's a very speculative notion, to say that there could be equipment from other civilizations that existed 1 billion years ago that arrived at our doorstep. Let's put zero funding to that. Let's ridicule. And I say, let's just look. That's what I was saying before. Let's just look. Okay, so over the past 5 years, we looked, we found the first 2 interstellar objects. The first one was discovered by my student, Amir Siraj, and myself. It's an interstellar meteor that was identified in 2014, and the US government now has a letter confirming that it came from outside the solar system. And it was a meteor, and it was tougher than iron. It was tougher than all 273 meteors in that catalog that the government compiled. So it's clearly an outlier. And moreover, it moved faster than 95% of all the stars in the vicinity of the sun. Again, an outlier. So we are planning an expedition to scoop the fragments of this meteor from the ocean floor near Papua New Guinea. That's the first interstellar object. Then you look at another, the next one is Oumuamua. That's what my book is about. Didn't look like a comet, didn't look like an asteroid. The explanation from the mainstream is it's a natural object, period. But it's an object that we had never seen before, such as a nitrogen iceberg chipped off the surface of a planet like Pluto. We have never seen something like that. Or a hydrogen iceberg. We've never seen anything like that. We don't know if nature makes hydrogen icebergs. Or it's a dust bunny, a cloud of dust particles 100 times less dense than air. Each of these explanations has problems. And I say, given that it's something that we've never seen before, we should consider the possibility that it's artificial. It was flat, it was pushed away from the sun without a cometary tail. There were a lot of anomalies that I describe in my book. So my point is, the first 2 objects coming from outside the solar system appear weird. They're outliers. They don't look like the rocks we had seen in our backyard. Just like the dark matter, most of the matter in the universe is not what we find in the solar system. Just like the sun is not made of the same stuff as the Earth. So nature is trying to tell us something. Let's be open-minded. And what do you find in response? Scientists saying, oh no, that's there is no extraordinary evidence to suggest that this is this extraordinary claim that it could be artificial is right. And I say, extraordinary evidence requires extraordinary funding. So first of all, you should put $10 billion towards the search of equipment from other civilizations, just like we put into the Large Hadron Collider. Put that in, then for decades, don't find anything, like we didn't find the dark matter as of yet for several decades. And only then you will be exactly at the same position as the dark matter searches are right now. Mm-hmm. Now, this question of whether there are others as intelligent as we are or more intelligent out there would have huge consequences to the future of humanity. Mm-hmm. So how can we ignore that? It's much more important than the search for dark matter. And that's what I find sort of, how should I say, a complete mismatch between the scientific community, the mainstream, and public interest and government interest. We can talk about the government. How is that possible? How did we arrive at this point where there is huge community of people speculating about extra dimensions, and that's part of the mainstream, where we have no evidence and they don't make any prediction about the Big Bang or singularities of black holes? So that's on the one hand, you have the mainstream, which has no evidence to support extra dimensions, no evidence for superstring theory, and that's mainstream. And at the same time, there is ridicule, no funding whatsoever, no, you have to apologize for working on the search for something that we are doing on this planet. And we know that there are many more, tens of billions of planets with similar physical conditions out there now, something that Carl Sagan didn't know 20, 30 years ago. So I say there is something that went wrong in academia. We need to recalculate academia because it's not attending to the interests of the public. It's not attending to evidence as the guide.
So this is not only controversial, this is rather taboo, the idea that aliens have visited us, at least in the form of the remains of their technology, which is what you're suggesting, right? Now here I see two moves, which are difficult. The first one is to kind of erase or edit Carl Sagan's mantra and other mantras that are repeated by people who supposedly defend science, like extraordinary claims require extraordinary evidence, which you've edited with your addition of an extraordinary funding. But that requires kind of to transform a topic into an acceptable research topic. This is a huge endeavor because it's not just about science itself, it's sociological, political, economical, and then open that so that research topic can be researched. And now here we have an example, and I think it's an exceptional one in your case, of somebody who has the ability to do both. But most of the time, both things don't coincide with the same person or the same group of people, right? So how do we maximize that these transformations can take place so that these topics can be investigated?
Well, let me first explain how I came to advocate for that. Basically, a few years ago, both my parents passed away. And that transformed me in a way, realizing that, we have a short life. And rather than pursuing honors and awards, which is pretty much the focus of academic work, where you're trying to gain popularity among your colleagues by behaving and going along the beaten path, I said to myself, why don't we do the right thing? We live for such a short time, okay? So I care less about how many likes I get on Twitter and what my colleagues are saying. That's not really relevant. I'm trying to use common sense. Now, the amazing thing that happened, I should say, is the US government, around the same time that I started to come out with this message, the US government started to come out as well. And in particular, the Director of National Intelligence, Avril Haines, submitted a report to the US Congress in June 2021, last year. And I actually met her in the green room of the Washington National Cathedral. We were both at the same public event together with Jeff Bezos and Bill Nelson. And I asked her, Avril, and by the way, she did a PhD in theoretical physics. That's the amazing thing. So she understands the way we think. Okay, so I came to her and I said, Avril, what do you think these things are, these objects that you're reporting about, this unidentified? What are they? And she said, I don't know. Now, you ask yourself, these are the US intelligence, she's the director of national intelligence in the US, okay? And she's a former physicist. She, you know, she's not just a career politician. So she knows what we know pretty much in theoretical physics. And to me, it illustrates the fact that there is classified data that we haven't seen that seems quite convincing, that illustrates that some objects behave in ways that you cannot understand as natural objects or as human-made objects. Because if they were behaving in ways that represent adversaries like Russia, China, other nations, you know, they would, you know, national intelligence agencies will never come out and report about it to Congress, because that would show that they don't perform their job. That would say, you know, here is a risk to national security. We have to deal with that, right? So we don't need to report about it publicly. But the fact that they come out publicly and the fact that she says, I don't know, means that they don't know. And I say that's the point where scientists should engage. Now, if we explain those objects as natural objects, or if we explain them as human-made objects, we did an important service to society. Very often you see mainstream scientists serving on funding committees, okay, of NASA, NSF, so forth. What do they say? They say, we don't want to fund risky projects because that would waste taxpayers' money. So very often these committees lean in the direction of conservative proposals for funding. I say, listen to your taxpayers. You're talking about wasting taxpayers' money? Ask your taxpayers if they're interested in studying extra dimensions, or they're interested in studying whether these objects are from another planet. Just ask them, and then recalibrate what you're calling waste of taxpayers' money. But the situation is that there is no federal funding for this, and now NASA established a study that will take a year and advise them whether to allocate funds in this direction. And I'm not that patient. And so I established the Galileo project. There were several multi-billionaires that visited the porch of my home. The porch of my home during the pandemic was amazing in the sense that so many people came by, quite unusual people, I should say, in terms of their wealth, in terms of their stature. And a few of them gave me $3 million to my research account at Harvard, and that allowed me to establish the Galileo project, which will study scientifically, using the scientific method, objects near Earth that may be of technological origin from another planet. And that includes rendezvousing with another object like Oumuamua that I mentioned before, going on an expedition to Papua New Guinea to scoop the ocean floor for the fragments of this interstellar meteor, and also looking at those unidentified objects that Avril Haines talked about. And we will see what we find. It's a fishing expedition. It's completely agnostic. It's using the scientific method. And by the way, you may ask, how did your colleagues react to that? Well, I didn't receive many congratulations on this exploration of the scientific method. In fact, some people say, oh, it probably will find nothing. But I say, we are using private funding for this, not even competing with other proposals. Why won't you just give your blessing to such a study? Because that's basically what the scientific method is all about. So you ask yourself, how is it that we are at this situation? That even, I would say, even the SETI community has an issue with this subject.
And there are many examples. And I would like to ask you about whether you think some topics are ripe for research, to search again. And well, I would say UFOs, but you can correct me because we're not talking only about UFOs, but you know what I mean? Like, this is an example. Another one could be psychedelic research.
By the way, I should say, the study of psychedelics is now, there is a new center in Stanford University, and the Harvard University is considering a new center in that. It's clear that psychedelics could have therapeutic effects on military personnel that went through trauma. This is becoming part of the mainstream gradually. So there are subjects that used to be tabooed. And the same, if you go back 1,000 years, there were people saying, don't open the human body, don't operate humans, because humans have a soul. And if you open the human body, you will hurt the soul of a person. Now imagine if scientists would attend to this guidance and say, never, never open the human body. Where would we be in terms of modern medicine? And so the good news is scientists didn't listen to that. We opened the human body. We now understand how it works. That's why we found this, mRNA vaccines to COVID-19. Without understanding the human body, we would never come across that. So that saved lives, and that helps us live longer than previous generations. And so my point is, there are subjects that are taboo. Just like in Galileo's days, the idea that maybe the earth moves around the sun was taboo, and he was put in house arrest. Today, he would have been canceled on social media, for sure. But if you were to ask those philosophers who put him in house arrest, if you were to ask them to design a mission that would reach Mars, they would never get to their destination because they thought that Mars moves around the earth. So I say reality is whatever it is. We just need to find what it is based on evidence.
Yeah, often the argument, which is not even an argument, is we've looked and there is nothing to see. Like,
no. Okay, so that's my point. How can we say that we looked if the first 2 interstellar objects were found over the past 5 years, okay, by astronomers, only over the past 5 years, and there weren't telescopes back in the days of Enrico Fermi when he asked, where is everybody? He didn't look through telescopes that we have right now. He didn't look through the windows to check if he has any neighbors. So, and also, of course, it's a mixed bag. The UFO bag is probably filled with lots of military objects, with lots of natural objects. So many of these reports are false, but I wouldn't classify the government reports as untrustworthy, because the day job of the intelligence agencies is to monitor the sky, and they are serious people. These are people that try to protect national security. So they see something through their satellites. They see something through they would be the first to find things because they monitor the sky all the time. So scientists, like astronomers, they look at a small area of the sky, a small field of view, and if something flies above the telescope, they ignore it. You never see a scientific paper saying 5 birds flew above my telescope at that time. Like nobody cares. And you need to monitor the entire sky. The only agency that does that is related to intelligence, to military. And if they say we see things that we don't understand, we should listen to them and try to figure out what these things are. I mean, these are serious people. So I'm not talking about anecdotal reports by civilians, because civilians are using cell phone cameras. They don't have, their aperture is only a few millimeters. The images are always fuzzy. I'm not talking about fuzzy images. I'm not talking about things from the past, like 50 years ago, 30 years ago. I'm talking just over the past few years, what the government is talking about. I'm talking about astronomical data that we collected over the past decade. These are things that were made possible thanks to the latest advances in telescopes, in instruments. And without those advances, without the satellites we have, we would never see those things. So let's look into that. Why is that a problem?
Am I right to add to the claim that it's quite likely that we've been visited by alien technology, that also there is data now coming out of the US government and so on that suggests that we are or have been visited by alien intelligence, not just their starships or their technological gadgets, but by themselves here on planet Earth. What do you think about that?
So I don't think that it's likely that there are biological entities visiting us, because the travel through interstellar space is very long. It takes millions of years. And moreover, there are big risks to biology. I mean, biological systems were selected by Darwinian evolution to survive on the surface of a planet like Earth, but not in space. However, we are developing the substitute for that, and that is artificial intelligence systems that can become autonomous. You don't want to send probes that will wait for guidance from the sender, because it takes tens of thousands of years for light to traverse the Milky Way galaxy. So you need the probe to be autonomous, to think for itself, to learn from experience. And artificial intelligence systems, machine learning, are capable of doing that. So that's what I see as our future, but it could be the past of other civilizations that send such equipment. And such equipment could potentially reproduce itself. These are called self-replicating probes that use the raw materials wherever they land and reproduce copies of themselves with evolution, just like biological systems do. That's an idea that was proposed in 1948 by von Neumann, John von Neumann, before the helical structure of the DNA was discovered. So he basically thought about an idea that is realized in biology before it was discovered, and then you can apply it to technology. So I think of technological selection rather than biological selection as what happens in space. Now, there are two types of things that you can imagine. Either space trash. These are probes like for example, New Horizons that we sent out, Voyager. Within 1 billion years, they will not be functional. So they would be space trash. And if they collide with an exoplanet, they will burn up just like a meteor. So maybe this meteor that we saw is something like that. But then you can imagine objects or probes that are functional, and they are equipped with artificial intelligence. So they're seeking some information, they're trying to do something. And this could be those unidentified objects. And we should look for them. Now, if you ask yourself, what's the chance that we will see a civilization or traces of a civilization exactly the same phase as we are? I would say it's extremely small, because we developed science and technology, the modern science and technology, only over the past century. And that's one part in 100 million of the age of the universe. So most likely there are civilizations far more advanced than we are, or far less advanced than we are, like we were 1 million years ago. Now, for those that are much more primitive than we are, we will need to travel to their planet and then land on the planet and start searching in the jungles for these primitive cultures. That's very tedious. That's a lot of work. Going to a planet, landing there, starting to search through the bushes and trees and finding those primitive people, or whatever they are. However, if they're much more advanced than we are, we don't need to do much. All we need to do is open our eyes and look around, because maybe their probes are around us. And that's my proposal for interstellar archaeology, so to speak.
Now, from a psychological perspective, many may believe that, of course, there's alien intelligence out there, and even that there are these technological artifacts that we may be detecting more of them, or that the ones that we saw were actually those. How do you think humanity writ large is ready psychologically, not to believe or to have likelihood that there's such things out there, but actually to know? Imagine that tomorrow the New York Times says, yes, alien found, right? And it's not a green little man, but like something along the lines you're suggesting. Do you think, and it sounds like a paternalizing question to the whole of humanity, but do you think we're ready? And also, how do you think it would transform our own understanding as human beings?
Well, definitely not ready, given what I said before, that even the mainstream community of physics, of academia, is not willing to discuss it freely. How can we be less ready than that? Just like saying, we don't know what the LHC would find, and then you find the Higgs and you say, wow, look at that, we didn't expect. So that's the kind of situation. I mean, the best analogy I can think of is my daughters, on the day before we took them to the kindergarten. They thought that they are the smartest in the world, because they compared themselves to the family member, to myself, my wife, and so forth. And they thought, oh, wow, everyone is paying attention to us. We are the most important humans in the world. And then we took them to the kindergarten, and they met other kids that are smarter than they are. That was a psychological shock, I can tell you. And humanity is facing such a situation, okay? Now, we don't have a protocol, because it's very different. In the past 70 years, the SETI community, the Search for Extraterrestrial Intelligence, went in the direction of looking for radio signals, okay? And that is the wrong approach, because that's just like trying to listen to a phone conversation. And you need the counterpart to be transmitting. And For example, suppose you want to find out if Wolfgang Amadeus Mozart existed, and you try to make a phone call. Are you Mozart? Are you Mozart? You will never get a phone conversation with Mozart. He died, okay? But you can find the music notes that he wrote and realize that he existed. So we can find perhaps relics left behind, physical objects, which are bound to the Milky Way galaxy, because chemical rockets cannot move faster than the escape speed of the Milky Way. So all of these objects will accumulate like in a basket, okay? And they will still be in the Milky Way. The light signals, the radio waves are, they are billion light years away now. They were sent by a civilization that existed a billion years ago, and they are dead by now. So most of the civilizations, if I had to guess, I would say are dead by now, and we are searching for radio signals just because we discovered radio communication a few decades, like a century ago. That's ridiculous. We imagine them being at our phase of development. Not only that, but we imagine them being alive, transmitting you. And even we right now are using fiber optics to transmit what used to be radio waves in the past. So that's a very childish approach to say, oh, we just discovered radio communication. Let's check if they are. And for 70 years, that was the thing that we did. And not only that, but the people that practice this approach have a problem discussing the set. In fact, they banned any discussion on UAP, unidentified aerial phenomena, from conferences on SETI. You ask yourself, how is that possible? The SETI community is banning discussions on objects. And I say, once again, something is wrong with academic culture. I'm trying to correct that by saying, just listen to common sense. And I'm sorry to say, but the public has its heart in the right place. The government has its heart in the right. It's just that something went wrong within academia, and we need to recalculate it. Basically, listen to the society at large, and also listen to evidence to guide us. If there is something intriguing that doesn't line up with our past knowledge, don't keep insisting that it must be rocks because you've seen rocks all of your life. Okay, let's examine it and get more data. How can we get more data? By giving funds to the search. You have to fund the search. You can't just say, oh, there is no sufficient data. We didn't do it with a Large Hadron Collider. We didn't say there is no extraordinary evidence for the Higgs, therefore we shouldn't fund the LHC. We didn't say that. We said, let's fund the LHC so that we can prove that Higgs exists. So the same thing. It's a self-fulfilling prophecy to say something doesn't exist and I don't fund the search for it, because it will always be true. It's just like the philosophers that refuse to look through the telescope of Galileo so that they will not be proven wrong.
How ironic and paradoxical that academics seem to be the biggest impediment to the progress of science.
Yeah, I mean, that is really strange. And you ask me, why is that this way? I think because the focus is on the wrong motivation. The focus is on showing that you are smart and protecting your expertise. So what does it mean? It means that to protect if you derive your self-esteem from your past knowledge, from your expertise, if you get honors and awards based on the fact that you worked for decades on a single subject and you are the world expert, you don't want to realize that you missed something. So if you worked on rocks in space, you want everything in space to be rocks, because if it's something else, you missed something, okay? And that is something you want, like, it's just like a flower coming out of the grass, and you want to step on it because you don't want anything to rise above the grass level, because you said throughout your life as an expert that there is only grass in this field. And so if you see a flower, you say that's grass, and you step on it so that nobody would see that this flower could rise above the grass. And that is the tendency to basically keep arguing that everything that you see is what you knew about. That's the tendency of, now, where does it derive from? It derives from human ego, from the desire to get honors, awards, and from jealousy. If someone else identifies something unusual, and that person is not part of the club of your expertise, which, you earned this position in the club of expertise for decades. So you worked very hard to show that you are, part of that club. And then someone outside of the club says something different. That bothers you. You want to smash that claim. so that the club would be protected, so that you would not be seen as someone who missed something, and also because of jealousy. Why would that person outside of my club get recognition? And jealousy is a very strong emotion. And I find jealousy to be very prominent in academia. And so in my mind, the explanation for where we are is twofold. One, people pretending to be experts. Second, and by pretending to be experts, also trying to show that they are smart, so they can do mathematical gymnastics and just to show off. Okay, so that's part of showing that you are an expert. And the second thing is jealousy. So if someone claims something different that deviates from the beaten path, if someone says, let's take the path not taken, you are jealous because here is someone that quote unquote did not earn being part of my club of expertise, and you don't want that to be right. And the way I saw that is when we discussed this interstellar meteor, our paper was declined by the experts. And the reason they said is, we don't believe the US government. And then the US government came with a letter from the Department of Defense, the US Space Command, saying, yes, we confirm the conclusion of the paper by Siraj and Loeb, which is very unusual. You never see that. It took them 3 years to do that. Where did I see that again? There was a paper I wrote just a year, 2 years ago with a postdoc, Hamza Padmanabhan, about black holes in the centers of galaxies. We suggested something, and then experts reviewed that paper and started arguing with us about semantics, and eventually the editor said, no, after a year, this paper should not be published. We submitted it to another journal. It was accepted instantly. And then that's not the fun part of the story. The fun part of the story is a year later, 2 teams of observers discovered exactly what we were talking about. They discovered it. Now, this team of observers were full of experts in the field. They didn't reference our work. So you go through the first phase where the referees are blocking you with no good reason. And the reason I say it's no good reason, because when we submitted to another journal, it was accepted instantly. And the second phase is, okay, then it's confirmed observationally in our case, and the experts would claim that they were the first to discover it. So my prediction is, if we find conclusive evidence for equipment from other civilizations, it's not as if there will be credit to my advocacy or to people would say, oh yeah, of course, we knew it from the 60s. There were lots of discussions about it. There is nothing new about it. But the fact that they tried to block it for years will not be recognized. They would say, of course, it was discussed in the 60s. Then there would be huge amount of funding. Then there would, newspapers will discuss it on a daily basis. Everyone would be engaged. Everyone, the young scientists would say, oh, of course, just like with dark matter, of course it exists. That's natural, just like birds exist, And by the way, birds exist, you think, oh, that's ordinary. But just in 1903, the Wright brothers were able to reproduce what birds are doing. So what I'm saying is, we might recognize it, but it will take us a while to reproduce whatever we find.
Well, talking to you, the time flies. So we're close to an hour. Let me try to wrap it up with a comment followed by a question. So in this series, we're constantly trying to see this hyper object, which is the future scientist, right? From different angles, disciplines, within science, also journalists, philosophers, and so on. And from what you've been saying in the last minutes, it turns out that apart from the so-called hard skills, what is really needed for the future scientist, I see, are what's called soft skills, because you're talking about creativity, authenticity, generosity, and so on. Now, basically, to be a better human being. But if I may say so, Alice in Wonderland, maybe the title for one of your great essays in Scientific American could be Avi in Wonderland. And then the question is how to escape the queen or the little queens from chopping your head. Now, if you're a big tree, strong tree like you are, maybe you chop theirs. But if you're a flower, like you're saying, like a PhD student or a postdoc, or even without, not with him, but without academia, you're stepped on, chopped immediately. So as a kind of recipe, so even if that culture, that human culture is cultivated, how to prevent all these little queens from chopping our heads?
That's exactly the biggest risk. I don't care about myself, okay? I don't care that people attacked me personally, which is pretty much, what happens in politics. You find it very often, but it's not supposed to be in the context of science. If you have an argument, we can discuss it. But anyway, so I don't care so much about myself. But the issue is really that young people are looking at it and saying, wow, look at what is the response to innovation, to deviation from the beaten path. If we want to get jobs, we must follow the beaten path, because otherwise they would not let us in.
Yeah.
And that's the biggest risk that I see to the future of science, because irrespective of what happens to me, the young people get the message that they should always follow the sermon of the church, so to speak. And that may be the way to discipline people in religious communities or in political communities, maybe, but not in science, because science is all about being open-minded, learning from evidence, and being fair, just talking about the substance, not trying to attack personally. And so I see that really as a big risk. And that's what I talk about in many of my essays. And I get private messages from people. In fact, there was a conference celebrating my 60th birthday in Martha's Vineyard just a couple of months ago. And a few young people came to me and said, look, we see what happens in academia. We are now junior faculty, assistant professors, and we are thinking of quitting. It's not worth it. If the culture is like that, what's the point? And that was very troubling to me to hear. And I ask those people in the mainstream, those people that try to chop heads, that try to suppress papers, that try to ridicule on social media. And by the way, a lot of the people on social media that say negative things are mediocre scientists. There are people, for example, the strongest voices are often from people who publicize science and do not practice science. These are people who didn't publish a single scientific paper over the past decade and a half. There are people like that. And one of them on his Twitter handle put, because I mentioned the fact that there are these advocates who didn't publish a single scientific paper, he was proud of that. He said, I'm the person who didn't publish a scientific paper over the past decade, as if that adds a plus among his followers. And I ask you, if that is the community of followers, what value is there to that? I mean, if you're not practicing science and you keep, raging at a practicing scientist and saying negative things on a personal level, is that really, something that we should bless? That's destructive, because the message it sends to the young people is, if you dare to say something different, this guy will jump up and down and say bad things about you personally, so that you will not have a career. And I say these people should be completely banished from attention, because they don't practice science. They don't know what is to do science. They just talk about science and attack scientists. So that is supposed to be out of the conversation. And the reason it was brought into the conversation is because they get some attention from, social media, from blogs. But what we should pay attention to are the practicing scientists who publish papers. And on that, we should follow the scientific method. We should discuss the evidence. We should make scientific arguments. We can disagree before the evidence is conclusive. In the Galileo projects, I have advocates and I have skeptics. Why did I put advocates and skeptics? Because I know that when the evidence is strong enough, they would agree. So when I see the two sides agree, I know the evidence is strong enough. So that's the way science makes progress, that people debate, and it's healthy to debate. And by the way, I always go by what Robert Frost said in his poem, that taking the road not taken, made all the difference for him, For me, it offers also the opportunity to harvest some low-hanging fruit, because nobody takes this path. There is a chance we'll find something really important there.
Yeah, and actually that's a common theme I realize now of the many so far, well, half a dozen at least people we've had on this series, like prominent scientists and thinkers, that they chose a road not taken, or as you say, they chose not to take the beaten road, knowing that they could be beaten for not taking it. So that seems like a common theme. Let me really end with one more question, because I want to give time to the rest of the audience to then make comments and questions. After the Oumuamua story exploded, you got all this attention and also the ability to influence more widely the media and so on, and of course be exposed to maybe more students, more politicians, billionaires, and so on. Now, throughout this exposure, what have you learned that you didn't know before? Because I've read from you years ago, you were already writing along these lines. You have a paper talking about creativity and students. So now that you have this new, like a telescope into a wider sample of the human population, what have you learned that gives you maybe hope or not about the future scientist?
Well, the basic thing I learned is that the world is much bigger than academia. Okay, so when you are immersed in academia, you often think just about your immediate environment or a little bit farther, what people say at conferences. That's a small portion of society. In fact, most of society is not even aware of what you're talking about. And after my book came out, I had about 1,700 interviews. It was only possible as a result of the pandemic. So the pandemic served a very important role. I didn't have to travel in order to have interviews. And I had most of the days were back-to-back interviews, from 8 a.m. till 8 p.m. It was very interesting because I met a lot of people from a very broad spectrum, including artists, including people from the humanities. And if I had to summarize it, I would say, it's the world is very big and interesting. And that also inspired me to write on a much broader set of topics. And in fact, I just submitted to the publisher my next book. It should appear in June 2023. Netflix is funding a documentary about my previous book. I had 35 filmmakers and producers contact me for doing something. And so altogether, I'm optimistic that eventually we learn something new. Okay. And of course, the expedition to Papua New Guinea is the next big thing that could happen. Where we received $500,000 in donations, and I still need another $1 million to make it happen. And if we get that money, we will go there hopefully in the coming months. And that will be a big thing, depending on what we find. If we find an alloy that nature doesn't put together that made this object, that would be a big result. So I think, there is opportunity here, and it has the potential of changing the landscape of the discussion. And that's what makes me optimistic, that, it's not up to what people say, it's up to what the evidence can show us. And the only way for us to maintain our convictions is for people to ridicule it, to block me, and to say bad things, such that we will never go after the evidence. That's the only way by which but believe me, by now, it's impossible for them to block me, because there are 100 people in the Galileo project. We got 800 requests from volunteers to be part of the Galileo project. Just think about it. I've been the chair of the astronomy department at Harvard for 9 years, okay, the longest serving chair, between 2011 and 2020, 3 terms. During that time, we tried to raise funds from donors for telescopes, for projects. It's really difficult. You go to many dinners, you don't get much. Here, I didn't try to do any fundraising. People came to the porch of my home and said, here is the money. So you think about it. What does it show you? It shows you that here is a subject that resonates with people. It's not talking about, what your colleagues think is interesting. It's talking about what everyone else thinks is interesting.
Yeah. Professor Avi Loeb, thanks so much for your energy, your courage, your wisdom, your determination. And I really hope that this effort of yours percolates beyond cosmology to the other sciences and also to humanity writ large, if we can say so. Thank you so much for agreeing to be in conversation with me. And now we'll have some time for questions, if you may. Thank you.
Thank you.
Yes, thank you both. If you would like to come in and ask a question or contribute to the conversation, you can use the raise your hand function, which you can find under reactions at the bottom of your screen. Otherwise, you can write it in the chat. I see we do have one hand up. Paul?
Thank you very much for your heroic efforts in changing and shifting humanity. The one question is, how will we listen deeply, and what will be our methods of communication? I think already, this morning I pulled up Congress. Do aliens exist? There's evidence. Then there's the whole threat to it, but now it is Congress suggests UFOs are aliens. But how can we listen without fear? I think this is a really creative edge that we're at. And in a sense, it's already happened. I think you're just pulling together the evidence. What do you see as sufficient evidence, enough evidence that would meet Sagan's extraordinary evidence? I mean, at what point in your career here would you say, yep, this is it?
Oh, it's very simple. Either we would have a high resolution image. As I said, the Galileo project is building a suite of instruments. We have them on the roof of the Harvard College Observatory already, and we are now testing them, and within a few months, we'll deploy them and start collecting data. So if we get a high resolution image, either in the infrared or the optical of an object, and we read off a label saying made on exoplanet Y, that's obvious. Or if the object behaves in ways that we cannot imagine human technology behaving, like, for example, you see a motion or acceleration close to the speed of light, we can't do that, okay? And you realize it's a real object because you find it, you see the infrared emission from it, you see the optical emission from it, so it's not a malfunction of the instrument you're using. So there are ways. Also, if we scoop the ocean floor in Papua New Guinea and we find material composition that clearly indicates some alloy that nature never puts together. It's not an iron meteorite, it's not a stony meteorite, it's some alloy of a material, maybe even artificial material. So that's an example of a situation, a scenario where it will be obvious beyond any reasonable doubt. And so, I think we can get that evidence if we only start exploring. And, what I would say, in terms of the response of the scientific community, when I was young, I served in the military, and we started in the paratroopers. And I remember a sentence being said that sometimes a soldier has to put his body on the barbed wire so that others can pass through. And I felt the barbed wire over the past year. And my hope is the young generation, after we demonstrate with good evidence that there is something out there, and everyone knows that there was this resistance, that the climate of the intellectual discussion will change to a point where, it will be clear that this is worth the attention of the mainstream, and also it will be worthwhile my pain, and so that's my hope. And it's all boiling down to conclusive evidence. It's not personal, it's not about me, it's not about people showing off. It's not about that. It's about finding what cosmic neighborhood we are living in. Just like you look at objects that came to your backyard from the street, and they don't look like rocks, okay? They look like a beach ball, or they look like, I don't know, a tennis ball. Then you can tell, okay, we have a neighbor. And so, it's purely experimental. That's the way science is driven forward. That's the way we learn new things. I'm not advocating for anything else. It's not a philosophical argument. And it's not about who is correct, who is smart. It's just about, let's find out. And the only way to find out is by funding the search.
Right. Now, 10 billion for CERN, 10 billion for Webb. Do you think Webb might give us some evidence? And
Yeah,
will it cost 10 billion for this intergalactic conversation? Is it going to cost another 10 billion?
So what Webb can tell us is Webb is 1.5 million kilometers away from Earth in the Lagrange point, L2. And that's an opportunity we never had before. If an object like Oumuamua comes along within the orbit of the Earth around the Sun, Webb will look at it from a completely different direction than the observatories on Earth. And then you can do parallax. This is a standard method in astrophysics, in astronomy, where you can monitor the three-dimensional motion of this object very precisely. We didn't have that when Oumuamua showed up. We had only the Hubble Space Telescope, which is very close to Earth. So by monitoring to very high precision the trajectory of the object, we can tell if there are any forces acting on it other than gravity. And for Oumuamua, there was a force pushing it. This way we can figure out whatever is happening and also study the surface of the object with Webb because it's sensitive to the infrared. So we can see the thermal emission from the object. We can maybe tell what the composition is. So Webb will be very helpful for that, the next Oumuamua, which we will get an alert for from the Vera Rubin Observatory that will start operations in Chile next year. And that's the dating app, I call it. We want to date the next Oumuamua, and we have a dating app, which is this Vera Rubin Observatory, the Legacy Survey of Space and Time, LSST. So we are ready for that. Now, the other thing that Webb can do is, for example, recently, just a few days ago, there was a paper from the Webb data that showed that it detects the emission from a single star at a redshift of 6.2 when the universe was just 1 billion years old. And so it has this extreme sensitivity. It can see a single star, take a spectrum almost of that star. And then I say, well, it could also potentially detect city lights on the night side of a planet. So imagine, like there is the nearest star is Proxima Centauri, and there is a planet there are 2 planets in the habitable zone of Proxima Centauri, and they are tidally locked, so they have a permanent day side and a permanent night side. And just imagine Webb looking at the night side of the planet and seeing evidence that it's not dark, that there is some, city lights there. That would be interesting. Or looking for industrial pollution in the atmospheres of other planets. So there are things that Webb can do. It was not designed for this purpose. I was actually on the committee that designed the Webb telescope back in 1995. And the goal was to look after the first stars, the first galaxies.
Thank you. Thank you very much.
Thank you for coming in. Bernard Carr, please come in.
Hi, Avi, and
Good to see you, Bernard.
thank you very much. I so much support your Galileo project, and admire the success you've had in raising funds. But also, I think the importance of what you're doing goes beyond the specific topics you talked about, i.e., looking for extraterrestrials. I think the comments you're making, the criticism that you're making, apply much more generally to a much wider range of topics, and that's why I find what you're saying so inspirational. I mean, sometimes even applying it in domains you might not approve of. I don't know, but nevertheless.
Oh no, I would approve, Bernard. Just to say a footnote to what you just said, I think that the search for the unknown resembles spirituality. So actually, religious people resonate with me much better.
Oh, right. Well, I wasn't going to mention the S word, but since you've mentioned it, I'm very pleased to hear that. And I have to say, I loved your analogy of the grass. Most scientists study the grass, and as soon as a flower comes up, they stamp on it. I think that's a lovely image, and with your permission, I may use it in my own talks.
Please do.
But on the other, what I wanted to ask, though, was something where I slightly disagree with you near the beginning of your talk. And this is to do with the time scale on which science progresses. I mean, if you look in some of the greatest discoveries in physics, they take a huge amount of time before they confirmed. I mean, gravitational waves detected in 1916, we had to wait 100 years. Black holes predicted in 1916, we had to wait 50 years. The Higgs particle predicted in the 60s, we had to wait 50 years. Hawking radiation.
But Bernard, women didn't have the right to vote for many years, and blacks in America were discriminated against for many years. That doesn't mean that the future has to be like the past. Let's make progress on a shorter time scale. So we don't want to surrender to the disabilities of the past.
No, but the point I'm making, I agree, but the point I'm making is that it seems to me that sometimes we just have to be patient, because it really does take a long time for theories to be confirmed. And I just think one should be wary of saying, well, we shouldn't be focusing on this because it will take more than the human lifetime. I mean, it's rather like the people who used to build cathedrals, and it would take more than a single builder's lifetime to build.
No, but okay. So my point is, let's build cathedrals with 3D printing. And let me give you another example. I used to visit a place, Garching in Germany, the Max Planck Institute, and they would always put me in a small room with a tilted ceiling, and I would bump my head against the ceiling when I took a shower. So I was pretty upset, and I told my wife, next time I go to Garching, I would ask for a double room. And when I got there, I said, the receptionist said, where is your wife? And I said, no, I'm alone. Oh, she said, okay, I'll downgrade you from a double room to a single room. I said, no, I want a double room. And so she said, oh, now I understand. She thought that I have an affair with another woman that will show up later. But I explained to her, look, I want some space. Okay. And then I asked my hosts, why is it that you have so little space? Okay. And they explained to me that there is this rule in Garching that no building should be taller than the church. Okay. And I said, why don't you make the church taller? So here is my metaphor. Let's make the church taller rather than say, oh, there has been this rule. So always we were slow at making progress. Therefore, in the future, we will be slow in making progress. I say that's unacceptable for us to wait 40 years. That dark matter will be acceptable. Fritz Zwicky suggested it in 1933. It started to become mainstream only 4 decades later. That's not acceptable. Let's make progress faster. The future does not have to be, to surrender to the mishappenings of the past. Let's make the future faster, the progress faster. We have better technology now. So I would say, the fact that people behave in this way that suppresses progress is unacceptable in my book. Okay.
Well, of course, I completely agree that one should aim to make progress as fast as possible. But I just think it may be a tad optimistic to assume that everything can be done on a human lifetime. That's all.
Well, I started doing astrophysics about 3.5 decades ago, about almost 4 decades. And then it was completely out of the mainstream to consider planets outside the solar system. And people were telling me, that's a speculation. There are exoplanets, and there was a report about one, and it was dismissed, and people said it's speculation. And so that's one subject that changed dramatically. Gravitational waves, I remember people ridiculing that and saying nothing. In fact, Ray Weiss, who got the Nobel Prize, told me that at MIT, his home institution, his colleagues in the physics department declined to give him support. And it went to the dean. The president of Harvard University told me that he was at MIT at the time, and the physics faculty advised him not to support LIGO, not to support the attempt to build a gravitational wave detector, from within the institution that Ray Weiss belonged to. And now, he got the Nobel Prize. So, you see it over and over again. I saw it in my own research many times, and I say, you can accept that, and you can say that's human nature. I don't accept that, and I say human nature needs to improve. And there are many examples of ways by which we improved human nature. I think, if we all agree on that, rather than letting those people dominate the agenda, we can dominate the agenda.
Yeah, okay. I think I'm just saying that one shouldn't say something is worth it just because it hasn't been experimentally confirmed, because we still haven't confirmed Hawking radiation after 50 years, but everybody accepts it's a really important result in physics.
Yeah, but what bothers me is not so much that some areas are not as developed as others. What bothers me is that you see mainstream communities working on things that are completely hypothetical, not proven, accepted, give each other awards, whereas a subject that is of great interest to society, that the government talks about, is ridiculed. That's what bothers me, because that shows a disparity between the two. And
I understand. Yes.
I think we should allocate funds in a way that reflects the public's interest. Because, let me repeat what people on committees say, let's not waste taxpayers' money. I say, I agree with you. What does it mean? It means that we should attend to the public interest.
I agree with that. And thank you, Avi, again.
Thank you.
Okay, we have Timothy. Timothy, would you like to come in?
Hello, thank you so much, Professor Loeb, and thank you, Alex. I've been absolutely bedazzled by your talk and so encouraged. I have this kind of gut feeling that it's the very, very top line scientists who kind of do get this. And I'm going to ask a little trick question. Who spoke these words? The new problem where we're stuck because all those methods don't work. If any of those methods would have worked, we would have gone through there. So when we get stuck in a certain place, it's a place where history will not repeat itself. And that's what makes it even more exciting. Because whatever we're going to look at, the method and the trick and the way it's going to look is going to be very different from anything we've seen before. Those words were spoken a few decades ago. I'm going to ask, who do you think spoke them?
I don't know, but it reminds me of what the soldiers often say, that you can hide in the crater created by a bomb because the chance of another bomb falling in it is very small. So every war is different from the previous. So every battle, also in terms of our knowledge, when we explore new territories, every attempt to gain new knowledge is different from the past. But I cannot imagine who said that. Who did?
Richard Feynman.
Ah, okay.
Magnificent. And he was also somebody, what I admire so much is what I call your rebellious curiosity. And surely that is what makes a great scientist. Rebellious curiosity, that you don't stamp on that flower that emerges spontaneously from the green grass, that you, again, grow up as a human being, as you obviously have done, and don't kind of bring all your personal stuff, your ego and your... So I personally would love to have my last comment. I wonder how it would suit us, probably not very well, if we, above every single scientific paper, stamped in bright red, would be a health warning which said everything written hereunder is partial and provisional. Because that's how it is, but it isn't, is it? And it's the way that we humans, as you've so beautifully laid out. Anyway, I just thank you so much.
Thank you. And the other thing that we should always keep in mind is what was, said to the emperors in ancient Rome. There was always a slave behind their carriage telling them, "Don't forget that you are mortal." To me, that's a big revelation, because how can we be proud of ourselves? Well, first of all, I should say, when we buy a car from a dealer, we can never have pride, like some people have, from how the car performs, because, someone else manufactured the car, someone else designed it. So how can we be proud just by buying a car? So, when I do things, I'm using my body, my brain, my thoughts, but that was manufactured by my parents. I just got it. How can I be proud of it? So that's the first reason not to be centered on your ego, because what you are using as your body, which allows you to do all these things, including scientific research, was given to you by others. Okay, so it's you yourself was not responsible for it. So that's point number one. Point number two is very often we are wrong. And the only way for us to educate ourselves is by studying nature. So we should be humble. And by the way, that's another link to spirituality, because religious people are often educated to be humble. And I think it's because they think about the unknown. And if you are a scientist that goes into new frontiers, you're also obsessed with things that are not known. And therefore, you should always be humble because you don't know. Okay, so the fact that you don't know shows that you are unable to actually come up with the answer before you see the evidence. And that's not the way that people who do mathematical gymnastics operate by. They say, oh, I can solve this mathematical problem and show that I'm smart. So then your ego gets a boost from that. And that is the loop that they keep going through.
Okay.
That, and that,
Okay.
I think is not the appropriate scientific method.
Thank you both. Can we take one more question? We have Ines who would like to ask a question. Would that be okay?
Please go ahead.
Come in then. You're muted. You're still muted.
Yeah, sorry. Hi, I'm so happy to meet you, everyone here. I'm so honored. So I feel I'm like those examples of the flower that's been stepped on sometimes. I'm a physicist myself. Well, I did chemistry, then physics, and now I'm working with a team that's also gone through that same experience, our director and all of that. But so I wanted, so many things you said have resonated so deeply with me and all our experience. But I wanted to ask you about specifically about the unification of scales. What are your thoughts on the topic of stochastic electrodynamics? Are you familiarized with that approach? What would you say about it? Because in our team, we have the let's say a model in which we say that it's vacuum fluctuations which are at the origin of dark mass and dark energy. And if you appropriately account for them, then it would come. So that's not new stuff. It's just stuff that's not being well understood, which is basically the vacuum fluctuations.
Yeah, this is very interesting. The only thing I would say is that what's surprising about, for example, the vacuum energy density, the cosmological constant, is that the energy scale is just milli-electron volt. So it's very small. And, we have experiments at that energy scale that do not reveal new physics. And the question is, why is it this energy scale and not the electron mass or anything else? So that's a puzzle, figuring out the energy scale. As to the mechanism, it may well be what you are describing. I think if you ask me, I think fundamentally what we are missing is a theory that unifies quantum mechanics and gravity that would provide us with the vacuum. It would provide us with also what happened at the Big Bang, at singularities and so forth. So I think that's the key. But on the other hand, we might not be able to imagine it unless we're guided by experiments. And it may well be that gravity is modified, that it's not dark matter. We will never find a particle. And gravity is modified in ways that, that represent our lack of understanding of quantum gravity. I wouldn't be surprised of that, even though it's not very popular right now. But it's possible.
Yeah. Like Eric Berlin's approach, which is also in the
That's one. Yeah, he was trying to explain the phenomenological results of MOND, the modified Newtonian dynamics, which appears to describe galaxies very well. I keep, whenever there is data on galaxies, I compare that to MOND, and it's remarkably successful that below a certain acceleration scale, you get a different behavior. That's surprising because dark matter did not need to behave that way. Although it can behave that. So anyway, I think until we find the dark matter particle, perhaps we should allow for modified gravity to exist. And perhaps that's all linked to how to unify quantum mechanics and gravity, that at low accelerations. And by the way, the acceleration scale is roughly the Hubble constant times the speed of light. So there might be something related to cosmology and dark matter and dark energy, because it also gives us the vacuum energy density
Yes.
So it all may be linked.
Yeah, it seems that there's like this gradient, energy density gradient across scales. So it probably is just finding well, that's kind of the models that we were working on. But that's
these different aspects of the standard model of cosmology could be linked, and it's definitely worthwhile exploring the possible link.
Yeah, and I just wanted to mention also that just last night I was reading an article. I didn't know Bernard Carr would be here. I just read his article on Nature, which is 40 years already, talking about this. It's the anthropic principle and the structure of the physical world, in which it's just amazing. I cannot believe I'm just meeting him now in this.
Well, Bernard has a lot to his credit, among which is the possibility of primordial black holes that he worked with Stephen Hawking in his PhD, and so he has a lot to offer. So thank you, Bernard, for joining us.
Thank you, Ines, for that comment. The paper was written, I think, in '79, a long time ago, which is partly why I said to Avi that somehow it takes a long time for ideas to become accepted sometimes.
Well, let's make it shorter so that you can enjoy the credits.
Oh, I agree with that entirely, Avi. Yep.
Yeah, I agree as well, Bernard. And you know what? It's for me very, very. I would like to know your thoughts on developments on that after, because you tapped into these fundamental ratios which are non-dimensional, constants, which seems to be extremely important. And so we have not delved deep into that. So at some point, maybe I can contact you, and because I have many questions on the topic.
I will put my email into a comment.
So on that note, I would just like to add that, of course, Galileo would have been delighted to see that what he talked about is correct by today's physics. And but however, he's dead. So I say, on the one hand, it's rewarding that the ideas that were promoted a long time ago eventually we come around to recognize that they were right. But it would be nice if we were to arrive at this conclusion while those people are alive, rather than put them in house arrest and then recognize that centuries later. So in the case of Bernard, it's just 40 years. He's still alive, so he can enjoy your comment. But let's make it happen on a shorter time. I think that would be good for the health of all scientists.
I couldn't agree more with you, Avi. I couldn't agree more. I'm so happy, and I have been following your work, and I think I know the blogger you're talking about. And
Thank you.
It's good to know that you're a strong tree. So thanks a lot.
Alex, any closing remarks?
Just a big thank you. To you, Avi, and also to the community that joins us every month in entertaining this idea of what the future scientist could be, which is an excuse to reflect on what we, the present human, are in a way. Thank you so much.
Let's make the future the present. That's my wish. So next time we meet, let's hope it will be a different landscape of the intellectual community.
Thank you. Thank you both. It was an honor to have you here today. And thank you everybody for joining us. It's been a wonderful session and we look forward to seeing you next month. Next month we have, Alex?
We have Tim Ingold.
Perfect. Yes. Wonderful. Thank you all and look forward to seeing you next time. Have a great week.
Thank you so much.
Bye-bye, everybody.
Have a good day. Thanks.